So now, let's really try some of those that has two radical terms. So now, in my example number 5, this time we're going to need a lot of writing space here. So my equation start out to be something like this. X plus 8 minus x minus 4 equals 2. So now you really are having two radical terms. And so to solve for this equation, to solve each of this equation, once again, you need to keep all the terms isolated. And what I see here, what I notice here, all the radical terms already on the left-hand side, and then all my non-radical terms already on the right-hand side. So I'm ready to go. Okay? So all I have to do now is, once again, okay, do not worry. You're just going to have to square both sides, whatever that is on each side. You just need to square all that. So on the left-hand side here is the ugly looking x plus 8 underneath the square root. Subtract square root of x minus 4. All that left-hand side, I'm going to throw that in parentheses and I'm squaring the whole quantity. And the right-hand side, -2, all squared. That's the first step. The second step, now, the challenging part in here is the right-hand side is easy, equals 4. The left-hand side here, you need to do all that FOILing. So think of all that here as square root of x plus 8 minus square root of x minus 4 times itself again. Square root of x plus 8 minus square root of x minus 4. You see you have two identical factors just like that. So now you're going to start FOILing. And pay attention to your FOILing. I'm going to go as slow as possible. Square root of 8, square root of x plus 8 times square root of x plus 8. That is going to give me square root of x plus 8 all squared, because I have two identical factors multiplied together. That's the first step in FOILing. The second one is square root of x plus 8 times negative square root of x minus 4. So I have a minus square root of x plus 8 times x minus 4. But then keep in mind, you can write it all under one root when you multiply square root. So x plus 8 times x minus 4. Because remember, you have two square roots multiplied together, so the two quantity can come all together underneath the square root. And then you're doing it again. Square root of x minus 4 times square root of x plus 8. You have another minus, and square root of x minus 4 times x plus 8. That is the result coming from these two factors. The last one is going to be a plus. Now minus square root of x minus 4 times minus square root of x minus 4 is going to be a plus, and then you have a square root of x minus 4 all squared. And all that here equals 4. So now let's say rearrange the terms a little bit. You can see that the two middle terms and the two root terms in the middle, they are identical terms with the same minus sign. So I'm actually going to have minus 2 times, and then this long square root, x minus 4 times x plus 8. The first square root term, the square cancel with the roots, gets me x plus 8, simply just that. The last term gets me just simply x minus 4, just that, and all equals 4. And so now, here, once again, at this point, I'm still adding up the roots. But the good thing is there's only one root remain. And so, what I need to do, I'm going to, once again, do the isolation of all the terms here. I'm going to need to subtract all the non-root terms to one side and leaving a root term on the opposite side. So now, what I can see here is that we have a -2 and with that root right here. So I'm going to subtract all that. I'm going to actually add all that square root term to both sides. And add 2 to both sides. And at the same time, I'm collecting like terms on the left-hand side. And so I have 2x plus 4 equals 4 plus 2 square root of x minus 4 times x plus 8. Once again, have you lost track of me? Let me roll back a little bit. Now, right at this step, right at this point, once again, right at this point, I want to, what I notice, even though I have a lot of terms here, x plus 8, and then x minus 4, and then there's a long square root here, but all that long square root itself is one radical term. So what I did here is I'm adding that same radical terms to both sides of the equation. And then at the same time, I was collecting the like terms. So x plus x gives me a 2x. 8 minus 4 gives me a 4. And on the other hand side, I have 4 plus 2, x minus 4 times x plus 8. So that's what happens to the equation after you arrange the terms. And then I need to arrange one more term. Now, on the right hand side, I still see some non-radical terms. So I'm going to subtract one more. Subtract 4 from both sides. And that gives me 2x equals 2 times x minus 4, x plus 8. Okay? But now, at least up to this point, things are becoming a little easier now. Now, I have a common factor of 2 on the two sides, so why don't we divide both sides by 2? Again. And then that gives me x equals r square root x minus 4, x plus 8. And then at this point, now things go back to those we have seen earlier. On one side you have just all the non-root terms, non-radical terms. On the right-hand side you have only one radical term, and that's a good thing. Now, what am I going to do next? We square both sides again. I'm going to square both sides again. So the left-hand side is the easier side, x squared. The right-hand side, after you square, it's going to become x minus 4 times x plus 8. Now keep in mind, when you square the right-hand side, the square root is gone. No more square root. But now, how do we handle this equation from here? The right-hand side, you need to FOIL it one more time. So I have x minus 4, times x plus 8, so it gives me x squared plus 4x minus 32, and equals x squared on the other side. And so with this equation here, what I'm seeing here is the x squared term is the like term on both sides. I can just simply subtract it away to cancel it off, and that gives me 4x minus 32 equals 0. Okay, and so now at this point, solving for x. In my bottom corner of the paper, you can also see that to solve for x, your equation is 4x minus 32 equals 0, adding 32. Now things are coming much easier now. That gives me 4x equals 32, dividing both sides by 4. That gives me x equals 8. Do not circle your answer yet. You need to check your final answer to see if it works. So now, how do I check? Let's go back to all the way at the beginning. And I'm running out of paper here, so let's go back to all the way at the beginning. Keep in mind, your found answer was an 8. You're going to go back to the beginning and plug that into the beginning equations. So the left side is a 4 plus 8 minus square root underneath the square root, and minus 4 underneath the square root. And let's see if it all equals to, I'm sorry, we had it messed up. 8 is what you plug in. Sorry. And let's see if it all equals to 2. Okay? So now I'm checking that. So this is my checking step. Okay? And so 8 plus 8 is a 16, square root of 16. And then 8 minus 4 is a 4, so we have square root of 4. And we're subtracting, and is it still equals to, after all calculations, is it all equals to 2? Square root of 16 is a 4. Square root of 4 is a 2. 4 minus 2, is that equals to 2? Yes, the answer is yes. So now, really, if you go back to your other page where you found your only solutions, yes, x equals 8. And that's how you final your answer. That's how you finalize your answer. So you can see that when things go to radical terms, all of a sudden it produces for you a significant amount of work for here. It's not really much harder. It's not really harder, but it's just going to be a lot of work for you to carry through. Okay, so let's try to do one more example like this with two radical terms so that you can get more comfortable with foiling involving